In this quick and dirty video, I'm going to illustrate how to fill out the data for the GPS data spreadsheet that we need for the strain analysis. I've got the spreadsheet partially filled, and what I've got in particular are station identification codes, which are 4-letter or 4-digit numbers. And we have 33 of these stations in the area of the Afar triangle. The information that is not filled in for many of these are the location name, latitude, longitude, elevation, and the velocities and their uncertainties. I have the links, the web links to the data that we need. We also, where available, would like to know the UNAVCO DOI database. So this is another web address. And if there's information about the network, operator, the operator's institution, that would be good. And then finally, we need to put down what the date was where we accessed the data. So let's work on one of these remaining bits of lines of data. We're going to look for a station called ASAB. So we're going to click on this link that is associated with it. And that looks like a pretty good record. It runs from about 2007 through 2016, more or less. So let's start collecting data. At the very top of the screen, you see station operator information from Rhinex headers. So I'm going to click on that. And it looks like this data set was collected by Robert Rellinger of the Massachusetts Institute of Technology. So in this case, I can just copy that name, come back to the spreadsheet, find the proper column, and stick that name in there. Oops, it didn't want to do that. Okay. And then I'm just going to type I'm just going to type MIT. Everybody knows what that means. We got this data on 11, so November 08 of 2021. Oops, let's just do 21. Okay, now in this particular case, I don't have a UNAVCO DOI database. And I know that because if I had one, it would be up here somewhere. So that's a bit of a disappointment. Here's the latitude, 13.063. 13.063. Make sure that you check everything as you go along. 13.063. Longitude 42.654. 42.654. Stop and check. 42.654. Height is 8.99966. Okay, 8.966. Check as you go. Okay, all those data are here in the coordinates. Now I've got a location name column. Here's where I get that. Southern Dancalia, Eritrea. Okay. You can see that that name extends beyond the edge of the column. So what I'm going to do is I'm going to grab the boundary of the column and stretch it out so I get that whole name in there. So the widths of these columns are things that we just kind of adjust as necessary as we create the data set. Okay, so now what else do we need? We need the velocities, and we need the start date and the end date of the data. The start and end date sometimes is given to you just in a Rhinex file, but if you can't get to the Rhinex file for whatever reason, another way of doing it is to come into one of these data sets like the IGS 14 data set up here and click on it, open it up, and you get this big array of numbers. But the very first one will be the first date that we have data from. So this is, it says 07 Feb 18. So that means that the first data was from 2007. It was collected on February 18th. So come down here, start date is February 02, 18, and 2007, 07. Okay. The end date, scroll down to the bottom of the data set, and some of these data sets are small and some of them are quite enormous. Really just depends on how many observations were made over what period of time. And so this last data is from 2016. It's collected on April 11th. So April is the fourth month, 04/11/16. Okay. So the next thing that we need to do is collect the velocity data. We're going to collect the velocity data in two forms, two reference frames. We're going to collect it for IGS 14, and we're going to collect it for the Africa fixed plate reference system. So we'll start with IGS 14. Click on that button in the time series plot, and then I'm going to click on the time series plot itself, and the topmost graph is the east-west velocity. Positive value is going east. Second one is north-south velocity. A positive velocity is going north. And the third one is the up, down, or vertical velocity, and a positive velocity is going up. So the graphics are quite nice. What I'm going to do is I'm going to focus in on this statement. Okay. The Midas velocity is a computed velocity by the University of Nevada, Reno, and that's the number we're going to want to record. So let's just open up our spreadsheet again. So IGS 14 east velocity in millimeters per year is 40.08. Now notice that there is no sign given here, so that's a positive number. Okay. Its uncertainty is 0.24. It's plus or minus 0.24. We're not going to put any sign for the uncertainties. Okay, so it's just 0.24. Now we're going to scroll down and pick up the north velocity, 27.95. 27.95. Check the numbers as you go. 27.95, 27.95. The uncertainty is 0.23. Okay. And the up-down velocity. Okay, here we have a negative number. Okay, so pay attention to the signs of those velocities. So this is a negative 2.52 millimeters per year plus or minus 0.66 millimeters per year. Okay, negative value, make sure you record that. No sign is given for the uncertainties because it's understood that it's a plus or minus situation. Okay, so now we've done all of the IGS reference frame velocities and uncertainties. Now we're going to go for the Africa fixed velocities. So I'm going to shrink that back down. I'm going to go back to the original page from UNR. I'm going to click on Africa plate fixed. Okay, and I'm going to do the whole thing over again. I'm going to blow up the screen so I have a good view of that number. The east velocity is 15.59. Check the number before you move on. The uncertainty is 0.24. Check the number before you move on. Now we're going to go to the north velocity. Okay. 11.98 millimeters per year. It's a positive number. 0.23 is the uncertainty. And the up-down velocity, okay, it's a negative number, so that means that it's going down. And we need to reflect that negative number in the data set, 2.52 plus or minus 0.66. Okay, so now we've got all of the data that is available, and we have no data available for the DOI file. So I'm just going to put NA for that. Okay. So anywhere in the file where you don't have any data, put NA. Okay. And so far in the first 7 bits of data that we've got, we have velocities for everything except one. Here's one station where there were no velocities listed. There's data, but they're insufficient to resolve a velocity. So in that case, we have NAs all the way along. So what would it look like if we actually had one of these DOI database things? Okay, so let's take a look at record number 7. It's from DAMY, station DAMY in Bati, Ethiopia. And here's the original station summary page. There's the Rhinex header that gives us the station operator. But now we've got something else down here. It says data attribution information from UNAVCO DOI databases, and then a link. Okay, so this is the link that we're going to want to copy and paste in this spot. Okay, now what's behind that link? Well, let's take a look. This link gives us the operator, it gives us the date that the data was collected from 2007, so April 25th of 2007 to January 6th of 2010. But the important thing, the most important thing, is that we can download the data. Now there's a lot of information here and a number of different formats for the data. But what I want to pull down or take a look at is the first page of the latest Rhinex data file. So we're going to download the latest Rhinex data file and take a look at its first page. Now this, depending on which GPS station we're looking at, this download can be pretty big. But what I'm going to do is I'm going to unpack the zip file that the data is held in, and the file inside is DAMY0060 period 10D. Now if I try and open that up in my Macintosh, it'll say, I have no idea how to open this up. What is this? So what I'm going to do so that I can see it is I'm just going to attach .txt to the end of that file name. And it'll say, are you sure you want to do that? And so let's just open up this text file and see what it looks like. Well, this Rhinex file is human intelligible, but it's not the prettiest thing in the world. It has a lot of information in it. It tells me that the data is attributed to Eric Calais, and I don't know who Louis is, what his first name is, at Purdue University. So that's information that I would put into the operator column of my data set. E-L-E-W-I. Okay. It's very important to properly attribute all of the data that you get. It tells this Rhinex file tells me what kind of instrument was used to collect the data, and information about the antenna and so forth. What I really want out of this is a little bit more accurate monument location. So that's the latitude. And there it is. And the longitude is right there. And it's there in the data set. And the elevation right there. Okay. Okay, and that's all we're going to get out of that for the moment. So we want to make use of the full Rhinex data set when it's available. And that's it. We've gotten to the end of the information I need to transmit. Just make sure that all of the data that you put in here is checked as you're putting it in, and then check it again and check it again, so we don't have any errors that crop up and make our ultimate analysis inaccurate. Okay, that's all. Let me know if any of this is unclear to you.